So we are going to use a piece of 3-inch material to cut down for our frame of our gyro. This is approximately what the gyro will look like when you're done. This is the stock material here. This is aluminum 6061 or 6065, 26511 in this case. 3 inches wide, 1/4 of an inch thick. We're going to basically make a square, but we always want to cut our part slightly more because our cut edge will not be perfectly square. So we want to give ourselves a little bit that we can cut off extra. So we're going to mark this off at about 3 1/4 inches or so. And to make that easier to see, there's a chemical called dicam, which makes it a little bit easier to scratch the line and see. It's available in blue and in red. Today we'll use a little bit of red. So I'm just going to kind of paint this on approximately where we think our line is going to be. A little fancy there. Let that dry for a second. One thing I don't like about red dicam is that it does look a little bit like blood. And when you're working with a lot of sharp metal, it's easy to cut yourself. So we're going to use this little guy. We don't need to be particularly accurate here, so we're just going to use a simple scale, a ruler, 90°, a couple of lines on there. And then we'll just go ahead and mark this straight off. And you can see a nice shiny line there on top of the red, nice and easy to see. So we're going to take this over to the horizontal bandsaw and cut that off. So this has a hydraulic release on it. We're going to bring this up, close that valve off there, and that will hold the saw up for us. We'll take our stock material. Allows us to use the blade right with our stock. Okay, and we're going to just look at it from above here. Make sure that line is right even with our blade. That looks pretty good. I'll come back over here. This is how we tighten the jaws on the vise there to hold your material in place. And now we'll turn on the machine. And we'll release the hydraulic valve so it comes down. And the machine automatically turns itself off when the cut is complete. Okay, and like magic, we've cut the piece off. Now you always want to be careful because there's usually a very sharp burr or edge that's left on there. That can sometimes be razor sharp, so you don't want to cut yourself on that. I'll usually come through with a little deburring tool and we'll remove that. Alright, let's use a deburring tool. It's one of these. We're just going to reach right along there, pull that towards us. You can see how that removes that sharp edge. Do it twice. Get that all cleaned up there. And this is just a good idea for two reasons. You're a little less likely to cut yourself as you're doing things. Also, when you go to load this into a vise, if there's any little burrs or something hanging out, it may clamp onto that instead of onto the actual piece. Therefore, your piece may not be square in the vise, or it may not be held as firmly as you think it's going to be. So, 3 inches wide, about 3 1/4 inches or so long. Then we'll take this over to the milling machine, and we'll clean up these edges and make sure that they're square to the factory machined edges. Okay, we're over at the Bridgeport mill, and there's two things that we need to do here before we're ready. What we're going to do now is face off one of the saw cut edges that we did there, and we want to clamp along one of the factory machined edges that we know is parallel to the other in our vise. But in order to make sure that our part is in there and not wonky, we will use a couple of parallel bars, and these are just there to lift the piece up off the bottom of the vise and hold it an even distance from across the bottom. The parallel bars, you always want to make sure that they're wiped down and clean, kind of like little sharp edges on your stock pieces. You don't want to have any bits or pieces that are going to get in the way of making sure that that's perfectly flat. So we'll put one on either side like that. We need to open the vise up a little wider. Put that piece of stock in there. Just like that. We want it to hang out just far enough so that we make sure that we won't hit the vise or any parts. But as far in as we can to make sure that the part is relatively rigid and steady in there. Okay. And as you're tightening the vise down, you want to gently tap on your part like so. This is just to ensure that the part is staying flat in there. Sometimes as you tighten a vise, the moving jaw here actually tilts back a little bit, and so this part will rise up. So we're just gently tapping it with a bevel hammer as it give this a good snag. Nice and flat, those parallel bars are in there. Just like that. All right, and then you'll know you'll have that part down in there flat when you feel a little bit of drag, a little bit of resistance on these guys back there. So it looks nice and flat. Next thing we'll do is we'll put our cutting bit into the collet here. Okay, so to face this part off, we're going to use a 1/2" end mill. This is a 3-flute end mill. Both the diameter of the cutting surface is a 1/2", as is the shank. That's going to go into what's called an R8 collet. Specifically, will go up into the machine, and this is what pinches and grabs the tool. As a drawbar pulls this thing up into the spindle here, this taper here will cause that to pinch shut and lock onto our cutting bit there. So there's a keyway in here. We need to rotate that around until the keyway slides in. So a 1/2" cutter is going to go up in there, and then from above, which you can't see on camera here, we're going to tighten that up into there. All right, on the top of the milling machine, there's a drawbar up here. We're tightening this screw up there to draw that R8 collet up into the machine. We will then use the spindle lock knob here. We pull that over to the side. That clamps a little belt around the spindle to keep it from moving. And that will allow us to then grab a wrench and tighten this back on there. One thing to mention as you're tightening this on there, we'll tighten this like this. Never, ever let go of the wrench. If you forget and leave this up here and turn the machine on, it will spin with the machine and cause all kinds of damage and havoc. So a good rule of thumb when you're tightening things up, just don't take your hand off the wrench. Lift it on there, tighten it down, take it off. Never lose your hand. Okay, the Bridgeport knee mill milling machine has 3 axes that we work with, X, Y, and Z. Our Y axis is controlled here in the front. We dial this guy towards us or away from us. Our X axis is controlled on either end by these, brings the cross table back and forth here, forward and backwards, and then the knee, or the Z axis, is controlled by this. Lift and raise the entire platform up and down. We usually turn this handle around so we don't knock our knees on the handles as they stick out. So that just comes out and slides back on there like that. Lastly, we can control the height of the spindle as well. So we have Z-axis control of the table height. We can also bring the spindle down this way as well. And usually a combination of the two is how we will achieve our ideal Z height. Once you have this down to a height that makes sense, and again, usually the shorter you keep your spindle in, the more rigid your setup will be, the cleaner your cut, less noise, less chatter. We're going to bring this guy down. You lock your spindle off with this little knob up here, and then everything's nice and fixed and ready for cutting. Okay, so I'm going to raise our table height. Good. Now we're going to drive our x-axis forward. Like so. Right. Then we'll bring our spindle down, put it there, and lock it off. Now the milling machine has 2 speed ranges and a gearbox that switches back and forth between the two. So on the front here, there's a knob that we turn only when the machine is running, and that allows us to pick what speed the cutter will be turning at. We have a high range indicated by the rabbit, RPMs that are available here. Slow range is the turtle, these are the RPMs that it's running there. So cutting in aluminum with a 1/2 inch cutter, we can probably move ourselves up into the high range of speeds here, and we're really looking at maybe 1,000 or 1,200 RPM or so. You guys should be able to calculate that based on the hardness of the metal, some lookup tables, and the diameter bit, and the number of flutes. To calculate the cutter speed for our mill, we'll take 300, or the surface feet per minute of aluminum, times 4 divided by the diameter of the cutter. In this case, a 1/2 inch, 0.5, gives us about 2,400 RPM or so. Okay, we're going to move the machine from the low range to the high range. That requires 2 different changes. The actual gearbox change here, to bring this over to the high speed range. Sometimes you need to turn the spindle down here just a little bit in order to get that gear to kind of lock in there. So once we have that in the high speed range, we're going to come around to the actual control box, and you notice the control box also has a high range up, low range down. In order to run the correct direction, that is counterclockwise with the bit, you need to make sure that your high range on the knob here is clicked up, while simultaneously the gearbox on this side is also set in high range. If you make a mistake in doing this, then you'll actually turn the cutter in the counterclockwise in the reverse direction of what you want. Alright, so we're going to go ahead and turn the milling machine on. This is at the high range. Always double check that your cutter is spinning in the right direction. Do need to make an adjustment to the speed. You can do it while it's running by adjusting this. Hear the motor run up a little faster, a little slower. We'll bring our spindle down, mid-range, lock that off, and we're just going to move forward until we touch. There we have touch. Again, we're not measuring anything at this point. We're just making sure to take very light cuts and just enough to clean up the edge of that part. This will give us 3 sides that are square or parallel to each other. And then we can measure for the final cut and get that to exactly 3 inches. Okay. And once again, I'm going to go ahead and deburr the part. The milling machine will also leave small burrs on there. Just taking out those edges so we don't cut ourselves or we don't accidentally clamp onto a burr and see the actual part. Alright, so that's relatively cleaned up there. One more edge here. Alright, nice and slow. Now, this is our finished side. These are our factory machine sides, so we know that this is 90 degrees to this is 90 degrees to this, but this side isn't necessarily parallel to this side. So our final cut will be measuring from our finished side to our unfinished side, and we'll use that to be exactly 3 inches, and we'll use some diching again to make that easier to see. Nice thin, quick light coating of that. Okay, so to get a little more precise of a measurement, we're going to use a set of calipers. We're going to run this out to exactly 3 inches. 300. Right on the 0 there. And we're going to tighten this guy down there so it locks it at exactly 3 inches. See that line on there reasonably well, and that's what we're going to cut back to. So just to double check, that gives us a square. There's our exact 3 inches across this way. So right on there, and right at 3 inches on this side as well, so you can see that. Okay, let's go take this edge off on the milling machine. Alright, we want to clean up our vise again, so we're going to use a little chip brush. Just clean up all these chips. Make sure we've got clean surfaces for clamping on. Put that in there. Again, just hanging out enough to make sure we're not going to hit the vise or anything. Just like that a little bit. Tap it down. Okay, looks good. right in there. Bring our spindle down, lock it off. And the y-axis forward. And this would be kind of a heavy cut to take off in one pass. We'll probably do this in maybe 2 passes. We'll just move a bit in by eye to about here, clean it off both passes, and then move it in and again go by eye to that line, and that should get us really close to 3 inches. Alright, you can see now that we've got that line very close to the edge. We should be, within a 1/16 of an inch or so, about 3 inches. What we're going to do now is switch over to using an edge finder, and this will allow us to pick up the machined back edge of our part, and then we will use the machine's coordinate system to move over precisely 3 inches and make the final cut on this side here. So what I will do now is change out our cutting bit for a edge finding bit, and I'll show you how that works in just a second. Okay, our edge finder uses a 3/8 inch shank, so we'll switch to a 3/8 inch collet. Fits. Slide this guy up. About an inch or so hanging out there, and we're going to tighten it from the drawbar above. First finger tight, tighten up to hold the part in there. And then we'll take it down. Okay. So this is our edge finder, and what's going to happen is we'll start off with this slightly off center. It's kind of spring loaded in there, and as it comes up closer to the edge, the rotating part will move until it looks like it's perfectly lined up, and then all of a sudden when you hit past the center point, it'll suddenly come off like this and start wobbling and spinning. And the moment that that kicks off, we know that we've found the exact edge, at least relative to the center of this part. And this has a diameter of 0.2 inches, so wherever we decide that we hit our edge, we need to subtract 0.1 inches, or the radius of the thickness of that part. All right, there's our edge finder. And we don't usually go below about 500 RPM, or above about 500 RPM in running neck. So I'm gonna bring this in, walk it off, bring the table forward, and we're gonna adjust our x-axis just a little bit here. I want that to be right on the machine surface. There we go. And I'm gonna bring the x-axis back. You see it get a little less wobbly. It's looking pretty smooth. Almost right there. And then something's going to kick to the side about now. Okay, now that we've found the edge, we're going to move the spindle out of the way. When I find that edge, I like to go ahead and set the x-axis to 0 over here on the digital readout. So you can see that x is at 0. The y is arbitrary at this point, doesn't matter. What we're going to do now is actually move the x-axis till we get to minus 0.1, because that's the radius of our edge finding tool. A little too far. So come back on that about right there. Doesn't have to be exact, but that's pretty darn good. Okay, so what we've done now is find that the center of our part should be lined up right over the center. It's always a good idea to do a visual verification on that. Now the center of our spindle is directly over the edge of our piece. Now we're going to use the edge finder to pick up the back or machined face of our piece of stock material. Once we pick that up, then we can move over precisely 3 inches and double check that our scribe line is in agreement with the 3 inches that we measure out. And we'll bring our quill down somewhere in the middle there. We're going to put this right about the middle of our piece, and then we'll bring our x-axis over. Touch the edge of the piece. It'll start to make the edge finder run a little more smoothly, right up until it looks like it's running very smooth. And the moment it kicks over to the side, we know we've reached the very edge of the piece. right there. Machine, there's the quill. And then we're going to look over here at our digital readout. And we're going to go ahead and reset that to 0. Okay, so that 0 that we just set puts the edge of this piece at 0 with this. But we know that the diameter of our edge finder piece down here is 0.2 inches. So we need to subtract 0.1 inches, or the radius, to find the very center of the spindle over the edge of this piece. So we'll move the x-axis back. Now that we've set our display to 0, we'll back that up to 0.1 off of that. And we're going to get that right up about 0.1, right on the money. Now, we know that the center of our edge piece here is right in direct line with the center of our spindle. Now we'll re-zero that, so 0 is over the edge, and then we're going to move our x-axis exactly 3 inches. Close enough. All right, once again, we're going to go ahead and 0 that. Now we know that the size of the cutter that we're going to use is a 1/2 inch end mill. So it has a radius of 1/4 of an inch. So we're going to go ahead and compensate for that. Move to 0.25. Right thereabouts. Now one more time I'm going to 0 this out. This avoids having to do any actual math or mental math or anything as I'm going. Now I know that when I put that 1/2 inch cutter in, the edge of that will be exactly 3 inches from the other edge. Now what we'll want to do is move the piece away. We'll go ahead and insert the cutter, bring the cutter back down, and make this finished cut down to the line. Okay, and we're going to switch out our edge finder for an end mill. So we'll loosen up. Go there. It's down. Sometimes you have to tap out the collet gently. So, there. Go ahead and turn on our mill and run that speed up. 2,400 RPM. Alright, and at that point our cutter will just touch the edge of our piece. And we'll continue to work that until we hit exactly 0. There, we'll take a final cleanup finish pass to take out that last 3/1000ths or so. Alright. Stop and double check our measurement before taking the final finish pass. So my caliper's on there. You can see we have right about 3 or 4 thousandths left to go. It's right on. Alright, we'll turn the mill back on. Finish up that last 3 thousandths or so there. Right on. nice steady feed as we put the part through. Alright. Alright, let's take a measurement. Okay, quick clean up those burrs real quick. Other side. Sometimes we can use a file or something like this. Measure that. There, about a half a thousandth or something over. I think that's fine.